All right, we're going to do problem solving with quadratics. We have a problem here. When doing a problem, it's always best to read through it once and then actually read through it a second time and highlight important information. So, the rectangular park measures 100 by 60 meters. Path of constant width is to be paved around the park's perimeter. The mayor wants to make sure the path does not reduce the area of the park by more than 10%. What is the max allowable width of the path? So, let's go through that again. A lot of information. Our rectangular, so we know its shape. Park measures 100 meters by 60 meters. Okay? A path of constant width, and that's important that it's constant, is to be paved around the park's perimeter. The mayor wants to make sure the path does not reduce the area of the park by more than 10%. What is the max allowable width of the path? Okay? So, to understand this, I'm going to draw a picture. It always makes problems much easier if we're able to put some type of visual to the question. Okay? So, we know we have a rectangular park. Something like this. Okay. And the park, before they've paved anything around it, is 100 meters by 60 meters. So what is the area of this park? 6,000. The area of this will be the length times the width. We'll call the length 100 and the width 60. So the area of this park right now is 6,000 meters squared. Now, they're going to be paving a path around this. So, I don't know what the best way to represent this is. We're going to get something like this. It's going around the perimeter of the park. I'm trying to make the width as uniform as possible here. Okay. So, a path is going to be paved around the outside of the park, and we don't know what its width is. So in other words, I don't know how wide that is, or this, but I do know it's going to be the same width all the way around. They said it was a constant width. Okay? So whatever I pave all the way around, the width will be the exact same. We don't know what it is, so we're going to call it our x. So the park's new area inside here is going to be what? They said we can't reduce it by more than what? By 10%. So what would 10% of 6,000 be? Okay, very good. So 6,000 by 10% is the same as multiplying by decimal 0.01, which equals 600. So we're allowed to reduce this park's area by 600 meters. So what's the new minimum area the park can be? If we're reducing it. So the old area was
5,400.
Good. The old area was 6,000. We're going to reduce the area of the park by 600. So the new area of the park, or the minimum area it can be, is 5,400 meters squared. Okay? So we reduced it by max 10%. Okay? So, our area, where's the highlight? Of this will be the grassy area. Okay? We got to figure out that width. Well, we know the new grassy area has an area of 5,400. Okay, this part here is 5,400 meters squared. We figured that out. Okay, and we know the old area was 6,000. So the area of this, we don't know how wide or how long this is going to be here, and we don't know how wide this is going to be because we've reduced the old area of the park. We do know the area of this. Okay, again, area is equal to length times width. We know that. This area is 5,400. Okay. And the area of this, just this purple part here, is the same as taking 60 and subtracting this part here. We'll do it in red. And this part here. We know this entire length is 60. Okay. And we're trying to find out the purple length, so we're going to reduce or subtract by those two red lengths. Okay, so in other words, we're getting 60, the number 60, and we're subtracting by 1, 2 x's. Okay, it's being reduced in length. So this purple length, and I guess I'll draw it in purple so it helps us make sense here. The purple length is 60 meters. That was the length of the whole thing. Subtract 2x. Those are those two widths of the park. Okay, this one here and this one here. We subtracted. Your quiz was a little different. It was adding something to it, right? This one we're reducing. That same idea we figure out for the length. So the old length here is 100 meters. But our new length, which we're trying to figure out in green, we'll say, okay, the new length is going to be what? That's right, 100 minus 2x. Reason being is because we started with 100 and we're subtracting by these two red areas again. And each of their measurements are x. Since there are two of them, we're subtracting by 2x. So the new length of this is 100 subtract 2x. Okay? What form of a quadratic does this look like right now? Anyone know? Looks so it's very similar to factor form. Okay? Now the only thing is to actually find out the values of x, we always got to make our equation equal to what? 0. We got to get this equal to 0. So I'm going to have to move this 5,400 to the other side of the equation. So now we're going to get into the algebra. When I move 5,400 over, we get 0. Oh, I don't want green anymore. We get 0 is equal to 60 minus 2x times 100 minus 2x. Subtract 5,400. Let's move this over because we have some room. Okay? So here's our major equation right now. Well, I'm going to expand this and try to simplify all my terms. We'll put this into standard form and then see what we can go with from there. So in order to expand this, what do I have to do? Oil, that's right. We want to distribute this, right? So we're going to distribute the 60 into both and the 2x into both terms. Then we'll be left with 0 is equal to 60 times 100. Anyone know? Good. 60 times negative 2x? Good. Negative 2x times 100? And negative 2x times negative 2x. Positive 4x squared. And we still have subtracted by 5,400. We'll collect our like terms. So these are two constants. We'll put those together. And we have two variables of x to the power of 1. We need to put those two together. Those are like terms. We also want to bring this term to the front. We always try to bring the variable with the highest degree to the front of an equation. Okay? So we have 0 is equal to our 4x squared. Negative 120x minus 200x.
320x.
Good. Negative 320x. 6,000 minus 5,400. Good. 600. Okay. So now we're in standard form. Okay. There's a couple ways we can go about trying to figure this out. I can do what to reduce this to start. Anyone know what I can do?
Divide out the x.
We don't want to divide out the x. We're trying to solve for x. So what's the way to reduce an equation? First step of factoring, always.
Oh, the square is minus b.
What's this stand for? Greatest common factor. We want a common factor. We always want a common factor. Always, always. Common factor here is going to be 4. We're going to take 4 out of each of these terms. Okay? We'll bring it as a common factor to the front of this equation. So we have 0 is equal to 4. Then we're left with x squared. Subtract 80x plus, what is it? 150? Yeah, that sounds right. 150. Good. Okay, so now we have a trinomial that's been reduced. We might want to try to factor to start this. Quickly do it with disappearing ink. Okay, this would be 1 and 1, 150, oh, 30 and 50. That would be a good one for 80, but it ends up being negative 80.
Yeah, so negative 30 and 50 negative.
Oh yeah, that'll work. Let me, Sorry. 30 times 50 is going to give us what? We're going to get 2 zeros like this. That's not that term. It needs to be 30 by 5. So what eventually we're going to figure out is there are no factors to this. Okay? So if I cannot factor this, how do I solve for x? That's right. We use the quadratic formula. Okay? So that means x is going to be equal to our negative b plus or minus. All right, let's see if everyone can say it at the same time. Square root. Hold on, slow down. I'm not as fast as you. So what's this? Hey, that's pretty good. Not bad. Okay, so we have this. Our a term is 1. That's our coefficient. We want the coefficients of each of the terms. B is negative 80, and C. Okay, so let's plug this in. X is equal to. This says negative 80, so when I plug it into negative B, what does it become? Positive 80. Plus or minus the root. We're going to try to solve a little as we go. 80 squared, anyone know? Top of their head? You guys are geniuses. Okay. 4 times A. What's 4 times 1? Okay. And 4 times 150? Yeah. And it's going to be a negative, right? So we have negative 600. And 2 times 1 is going to be... Good. So equals 80 plus or minus the square root. What is 6,400 subtract 600? 5,800. I love that number. 5,800. Okay. The roots of 5,800 or 5,800. Rooted 76.15, we'll say. Okay, so I have 80 plus or minus 76.15. Is that what I said?
Yeah.
Right number? Yeah, okay. Divided by 2. This is the point where what needs to happen?
You add one, you subtract, you use the addition sign and this.
That's right. Because it's plus and minus, when we're rooting something, we get 2 answers. The root of 5,800 is equal to 76.15 positive and negative 76.15. So because there are 2 answers, we split the question. Come on, plus. There you go. Okay. In one of the questions, we're going to get x is equal to 80 plus 76.15 divided by 2. And the other question, what's it going to read? That's right. 80 subtract. Okay? There are 2 answers when we root something. Divided by 2. So we'll use our calculators to figure this out. Plus 80. Where's plus? Divide 2. 78.07. 78.0. That sounds like a ridiculous amount. And the other one, this is probably going to be our answer. 80 subtract 76.15 equals divided by 2. 1.925. That makes much more sense. What did it say it was? 1.925. I just remember. Okay. So we have 2 answers here, both positive. So technically logical. I can take away 78 meters or I can take away 1.9 meters. Let's go back up. There are 2 answers. When we compare this to what needs to be done above, only one of these is going to make sense. So let's go up. Way up to the top. Is it logical to take away 78 meters from here and 78 meters from here? Who says yes? Okay. So, as Mac just told us, we only have 60 meters of width to work with on this park. So if I take 78 from here, I've already gone past that. And then if I take another 78, I'm destroying some person's house inside the park, okay? This is illogical. We can't take away that much of the park because there's just not that much of the park. But we can take away 1.925 meters. That would make sense. If we take away 1.925 meters from here and 1.925 meters from here, these 2 sides, And we do the same thing down here. We take away 1.925 meters and 1.925 meters. Okay? Those are logical answers. So when we go to the bottom, this one doesn't make sense. This is the answer. Oops, didn't want it to look like that. That's the answer we want to be working with. So let's actually check this. We knew the old, I'm going to quick rectangle here. We know the old one was 60 and the other was 100, okay? Our new length, we said, needed to be 100, subtract 2x. Well, we know our x value to be this. So let's figure out our new length. It would be 100, subtract 2 times 1.925, okay? Because that's what our x, that's the amount we're taking away. So 100, subtract, bracket, 2 times, somebody already get the answer back there? 9615.15. And our width was 60, subtract 2 times x. Okay, this is our way of checking. Can't remember what the question asked us in the end. What is the maximum allowable width path? We figured out the maximum allowable width path. It was this. But let's actually figure out what the new widths and lengths are to see if this actually works. This becomes 60, subtract, bracket 2 times 1.925 equals 56.15. Verify that. Nobody answering? Okay. So if these are the new widths and lengths, I should really have drawn a better. So if the new length is 96.15 and the new width is 56.15, let's figure out if that area makes sense. How big was the area supposed to be? That's right. Remember, this was our old area. So let's see if these numbers make sense. We know how to do area, right? Area is equal to length times width. So we'll multiply. Come on, there you go. 1.5. Now remember, we rounded a little. Let's see if this works. 96.15 times 56.15 gives us, yeah, we're off by 1 point something meters here. So we did a little bit of rounding in our error, but that's pretty much what we're looking for, almost 54,000 meters. Okay? So we know these numbers are logical. They make sense. They get us the area we need, and we're not destroying homes on the side of the park.